The German engineer stood in the center of the vast Kummersdorf proving grounds, the cold April wind of 1943 biting at his face. But he didn't feel the chill. His entire world had narrowed down to the olive-drab steel behemoth sitting silently on the concrete pad before him. It was a medium-tank M4A1, a machine the Americans called the Sherman, but the white stenciled letters on its hull identified it by a more personal name. War Daddy 2, serial number USA 3067641. He ran a grease-stained hand along the cast hull, feeling the texture of the metal. He was looking for flaws. He was looking for the crude, hasty workmanship that German propaganda had promised him characterized American industry. They were supposed to be inferior, mass-produced junk built by a nation of cowboys who didn't understand the art of war. But as his fingers traced the weld lines, a pit formed in his stomach. The welds weren't just strong. They were uniform, machine-made, terrifyingly consistent. There were no rough edges, no signs of a welder rushing to meet a quota. It was the first physical evidence of a realization that would eventually paralyze the German high command. While Germany was meticulously crafting armored masterpieces by hand, the United States was printing tanks. This specific machine had been captured in the burning sands of Tunisia 2 months earlier, on February 22nd, amidst the chaotic American retreat following the Battle of Sidi Bouzid. That battle had been a tactical disaster for the U.S. 1st Armored Division, smashed by seasoned panzer crews. In the confusion, the crew of War Daddy 2 had abandoned their mount, perhaps due to a fuel shortage or a minor track throw. But the provenance of its capture was less important than how it arrived in Berlin. The official Wehrmacht recovery report sat on a clipboard nearby, and its contents were baffling to the engineers. When the German recovery team found the abandoned Sherman in the desert, they didn't need a heavy recovery vehicle to drag it away. They simply climbed in, pushed the starter button, and the engine roared to life on the first turnover. They didn't load it onto a trailer immediately because they didn't have one available. Instead, they drove it. They drove a captured enemy tank over 200 miles across the punishing North African terrain to the port of Tunis. For 4.5 days, it ground through sand, dust, and heat. It did not overheat. It did not throw a track. The transmission did not fail. To a German tanker accustomed to the fragile, high-maintenance temperament of a Tiger or a Panther, this reliability was not just impressive. It was alien. The tank was then shipped across the Mediterranean, transported by rail to the Reich, and delivered to Kummersdorf, the heart of German weapons testing, for a complete autopsy. Kummersdorf was not a place for amateurs. Located 20 miles south of Berlin, it was the birthplace of the German rocket program and the testing ground for every major weapon system the Reich produced. The engineers here were the elite, the men who had dissected the Soviet T-34 in 1941 and designed the Panther in response. They approached the Sherman with the arrogance of master watchmakers asked to evaluate a cheap alarm clock. They had their calipers and their notebooks ready, fully expecting to write a scathing report that would make the generals in Berlin laugh. They started with the armor protection. They measured the glacis plate at 51 millimeters and the sides at 38 millimeters. They noted the slope angles and the casting quality. It was adequate, certainly, but not revolutionary. The high-velocity 88mm gun of a Tiger could punch through it from over a mile away. The engineers nodded to one another. This was exactly what they expected, a mediocre shell. But then they opened the rear engine hatches, and the laughter died in their throats. Sitting inside the hull was a Continental R975 radial engine. It was a beast of a machine, originally designed for aircraft, repurposed to drive a 30-ton tank. It produced 400 horsepower, air-cooled, rugged, and compact. The engineers immediately began calculating the power-to-weight ratio. The Sherman weighed roughly 30 tons. The engine gave it nearly 13 horsepower per ton. They compared this to their own pride and joy, the Panther, which was currently plaguing production lines. The Panther weighed 45 tons, but achieved only 15.5 horsepower per ton despite its massive, complex engine. The American tank was lighter, punchier, and far more agile. But raw power wasn't what terrified the head engineer. It was the accessibility. He stood on the rear deck and looked down into the engine bay. Every major component, the magnetos, the oil pumps, the filters, was accessible through large, well-designed hatches. He realized that a mechanic could change the oil in this tank in minutes. A spark plug change, a nightmare operation on some German vehicles, could be done by the crew in the field with basic tools. The German philosophy of tank design treated the machine as a closed system that should only be touched by factory-trained specialists. The Maybach engines in the German heavy tanks were marvels of engineering, but replacing one often required a crane, a dedicated workshop, and 24 hours of labor. The Americans had built a tank that assumed it would break and made it easy to fix. The Germans had built tanks that assumed they would never break, and when they did, they became abandoned steel bunkers. The inspection moved deeper into the machine, and the sense of dread compounded. They hooked up the fuel lines and prepared to run the powertrain on the test stand. German engineers were accustomed to the soundtrack of armored warfare, the screaming metallic whine of spur gears grinding against each other under the immense torque of a tank engine. It was the sound of friction, of metal eating metal. When the driver engaged the Sherman's transmission, the engineers leaned in, confused. The tank didn't scream. It hummed. It was a low, smooth mechanical whir that spoke of impossible precision. One engineer waved his colleagues closer, unable to believe his ears. They dismantled the transmission housing to find the source of the silence, and what they found inside silenced the room. Herringbone gears. Inside the gearbox, the Americans had used double helical gears, teeth cut in a V-shape that meshed together smoothly, canceling out side thrust and distributing the load evenly across the face of the gear. This was not just a design choice, it was a flex of industrial might. To manufacture herringbone gears requires complex, multi-axis milling machines and specialized cutting tools made of tungsten carbide. Germany did not have these tools. The Allied blockade had strangled the supply of rare earth metals like tungsten. German industry had reverted to straight-cut spur gears because they were simpler to manufacture and didn't require exotic materials, even though they were noisier and wore out faster. The engineers looked at the glistening American gears and realized the implication. A Sherman transmission could likely run for 3,000 miles before needing an overhaul. The final drives on a Panther tank had an average life expectancy of 100 miles. Not 100,000, 100. A Sherman crew could drive their tank from the beaches of Normandy to the streets of Berlin on a single transmission. A Panther crew would be lucky to make it from the railhead to the front line without stripping a gear. The Americans were building tanks with the durability of locomotives, while Germany was building tanks with the lifespan of a grenade. But the Americans hadn't just out-manufactured the Germans, they had out-innovated them in the most humiliating way possible: electronics. Attached to the 75mm gun mount was a small, unassuming metal box with heavy electrical cables running to a gyroscope motor near the gunner's position. It was a Westinghouse gyroscopic gun stabilizer. The German engineers stared at it in disbelief. They understood the theory. They had experimented with stabilization for naval guns and aircraft, but the idea of miniaturizing such delicate, complex electronics and installing them in a mass-produced medium tank was beyond their industrial comprehension. They carefully disassembled the unit, studying the servo motors and the gyro. It wasn't a perfect system. It only stabilized the gun in the vertical plane, meaning it didn't allow for sniper-like accuracy while moving at full speed over rough terrain. But the engineers realized its true tactical value immediately. It kept the gun roughly on target while the tank was moving. When the Sherman stopped to fire, the gunner was already aimed. He could fire in seconds. A German tank, with its heavy, unstabilized suspension, would rock back and forth violently when it halted. The German gunner had to wait 10, sometimes 15 seconds for the chassis to settle before he could take an accurate shot. In a tank duel, the man who shoots first usually lives. The Sherman was designed to shoot first. The Germans tried to calculate what it would take to replicate this system for the Panzer divisions. The answer was despair. They lacked the copper, they lacked the precision electronics industry, and they lacked the ability to produce such delicate instruments by the tens of thousands. By June 1943, the technical evaluation was complete, but the German High Command wasn't interested in a lecture on gear ratios or maintenance hours. They wanted a show. They ordered War Daddy II transferred to the proving grounds at Hillersleben for a comparative demonstration against the Reich's newest hope, the Panther. The audience was a collection of generals, armaments ministers, and procurement officers, men who decided where the steel and the money went. They didn't want to hear about logistics. They wanted to see German superiority confirmed. They set up a climbing test, a steep 30-degree slope of loose, shifting sand designed to test the traction and torque of the machines. The Panther went first, with its wide tracks designed for the mud of the Eastern Front and its massive 700-horsepower engine. The German cat roared up the hill. It was magnificent. The wide tracks floated over the sand, biting deep, and the tank crested the summit without straining. The generals applauded, nodding to each other. This was German engineering. This was the master race in steel. Then the American tank approached the slope. War Daddy II was equipped with standard rubber block tracks, designed for long road marches and durability, not for climbing loose sand dunes. The driver gunned the engine. The radial engine roared, the tank hit the slope, and the tracks began to spin. The rubber blocks couldn't find purchase in the shifting grit. The tank slid sideways, the engine whining in protest, and eventually slid backward to the bottom of the hill. It had failed. The generals cheered. They clapped the engineers on the back, smiling with relief. The demonstration had proven exactly what they wanted to believe. The American tank was junk. It couldn't even climb a hill that the Panther had conquered effortlessly. They saw the failure on the slope and dismissed the Sherman as a threat. But the engineers standing on the sidelines didn't cheer. They watched the generals celebrating with a sense of impending doom. They knew what the generals were too blind to see. The Panther had won the sprint, but it would never finish the marathon. The generals saw a tank that couldn't climb a sandy hill. The engineers saw a tank that had driven 200 miles across a desert to get to the hill in the first place. They knew that the Panther, for all its prowess on the test slope, was a logistical nightmare that broke down if you looked at it wrong. They knew that while the Sherman had slipped on the sand, its transmission was still pristine, its engine was still cooling efficiently, and its gun was still stabilized. The failure at Hillersleben was the worst thing that could have happened to the German war effort, because it validated a delusion. It convinced the leadership to keep pouring resources into high-performance, fragile thoroughbreds instead of building reliable workhorses. The engineers looked at War Daddy II and saw the future of the war. They saw a machine that didn't need to be perfect, it just needed to work. And it worked every single time you pushed the button. As the generals walked away, confident in their superiority, the head engineer looked back at the American tank. He realized then that the war was already lost, not because the Americans had better soldiers or better generals, but because they had built a machine that respected the reality of war, that the tank that actually arrives at the battlefield is infinitely superior to the supertank that is stuck in a repair depot 50 miles to the rear. Albert Speer, the Reich Minister of Armaments and War Production, was a man obsessed with efficiency. He had single-handedly reorganized the German economy, tripling weapons production in 1942 despite the intensifying Allied bombing campaigns. He believed that German engineering genius, if properly managed, could outproduce the combined industrial might of the world. But when Speer examined the reports on the captured Sherman tank, and when he looked at the machine himself, he reached a conclusion that would haunt him for the rest of his life. Speer was not a soldier. he was an architect and a manager. He looked at war not as a clash of heroes, but as a problem of supply chains and industrial output. While the generals at Hillersleben were high-fiving over the Sherman's inability to climb a sand dune, Speer was looking at the bigger picture. He read the reports from Italy, where field commanders were praising the captured Shermans for their ability to cross terrain that German experts considered impassable for armor. He noted the engine's power-to-weight ratio, which allowed the American tank to maneuver on level ground with an agility that the heavy Tigers could never match. But what truly terrified Speer was the realization of the philosophical chasm between the two nations. Speer understood that Germany was building complex, high-maintenance machines that required a dedicated rail network to move. A Tiger tank could not simply drive 300 miles to the front line. It would break down before it got halfway there. It had to be loaded onto a specialized rail car, transported to a railhead near the combat zone, and then carefully driven the final few miles. The United States, on the other hand, was building a mobile force that could drive itself to the war. The Sherman wasn't just a tank, it was a self-contained logistical unit. It was designed with the understanding that rail lines would be bombed, that trucks would be scarce, and that the tank itself needed to be the primary method of transport. Speer realized that no amount of German technical superiority could overcome a logistical philosophy that was simply better. The Americans had prioritized three things: reliability, maintainability, and mass production. German industrial philosophy prioritized one thing: combat performance. The Americans had made specific design choices that German engineers scoffed at, but which Speer now recognized as genius. They accepted a less powerful 75mm gun because it was proven, reliable, and possessed a high rate of fire with ammunition that was easy to manufacture. They accepted thinner armor because it reduced weight, which saved the transmission, which saved fuel, which meant the tank didn't break down. They accepted a simpler, taller silhouette because it allowed for a spacious interior where the crew could work efficiently and where the engine could be easily accessed. Germany couldn't compete with that. Not because German engineers weren't brilliant, but because they had optimized their machines for the wrong variables. The men who felt the weight of this error most acutely were not the politicians in Berlin, but the tank crews on the eastern and western fronts. Alfred Rubel was a tank commander in the 503rd Heavy Panzer Battalion. He was an ace, a man who survived the war with 57 confirmed kills in Tigers and King Tigers. He knew exactly what German tanks could do. He knew their guns could crack a T-34 or a Sherman from 2 kilometers away. He knew their armor could shrug off incoming fire like rain. But he also knew the fear of turning the key and hearing nothing. Rubel's unit often used captured Shermans for recovery duties and supply runs. In his memoirs, he compared the Sherman to a reliable civilian car. "You pushed the button," he said, "and they started." With a Tiger, starting the engine was a ritual. You had to check the fluids, preheat the engine in cold weather, tension the tracks, and worry constantly about the delicate transmission shearing a gear if the driver was too aggressive. The Sherman just worked. It was boring, it was ugly, and it was dependable. German tank crews loved their Tigers and Panthers when they were running. The problem was that by 1944, they were rarely running. The statistics were damning. German armored divisions frequently reported operational readiness rates of 35 to 45%. This meant that at any given moment, more than half of the Reich's tank force was effectively non-existent, sitting in repair depots or abandoned on the side of the road waiting for parts. American armored units, by contrast, consistently maintained readiness rates above 85%. When an American commander looked at his map and saw a tank battalion, he knew he had 50 tanks ready to fight. When a German commander saw a Panzer battalion on his map, he knew he might have 12 tanks operational, 10 that might run if they were lucky, and 30 that were essentially steel pillboxes lacking engines or tracks. The numbers told the story that Goebbels' propaganda tried to hide. Superior capability is useless without availability. The Normandy campaign in the summer of 1944 became the graveyard of German engineering arrogance. It proved everything the engineers at Kummersdorf had feared back in April 1943. During the desperate retreat from France, as the Allied air forces pounded the roads and the front collapsed, the fragility of the German war machine was exposed. Post-war analysis showed that roughly half of all Panther tanks abandoned in France had not been destroyed by enemy fire. They had been destroyed by their own crews. Thousands of tons of the world's most advanced armor, equipped with the deadliest guns, were blown up with demolition charges by weeping German crews because of mechanical breakdowns. Imagine the psychological toll on a panzer commander. You are sitting in the ultimate predator. You have a gun that can kill anything on the battlefield. You have armor that nothing can penetrate. But you are standing on the side of a dirt road in Normandy, watching smoke pour from your final drive because a 50-mark gear failed. And as you rig the explosives to destroy your own magnificent machine, you watch a column of inferior Shermans drive past you, their engines humming, their tracks clattering, driving all the way to Paris to win the war. They didn't beat you because they were better warriors. They beat you because their tank didn't break, and yours did. The Battle of the Bulge in late 1944 was the final confirmation of the disaster. Hitler gambled his last reserves of armor on a massive offensive through the Ardennes. He sent King Tigers and Panthers, the pinnacle of German engineering, into narrow, snowy roads. It was a logistical suicide mission. By the end of the battle, 60 to 70% of German heavy tank losses were non-combat related. They ran out of fuel because their engines were thirsty beasts. They broke down under the strain of the terrain. They blocked the roads for their own retreat. The Americans, meanwhile, rushed reinforcements to Bastogne, using the very mobility the Germans lacked. The engineers at Kummersdorf had seen this coming. They had tried to look past the showy hill-climbing demonstration at Hillersleben and focus on the internal components, the manufacturing philosophy, the brutal mathematics of reliability. They had documented every advantage the Sherman offered. They had written reports explaining exactly why American mass production would win the logistics war. Nobody had listened. The generals had watched the Sherman slide backward on a sandy slope and walked away confident that German engineering was superior. Germany could not simply adopt the American philosophy. It was trapped by its own choices. The strategic materials required for the American style of manufacturing, the tungsten for the cutting tools, the copper for the electronics, the rubber for the tracks, were not available. The Allied naval blockades had strangled the Reich's supply lines. But more than that, the production culture couldn't change fast enough. German factories were organized around the concept of the Meister, the skilled craftsman who hand-fitted components to ensure perfection. American factories were organized around the assembly line, using interchangeable parts that required no fitting. To convert the German system to the American system would have taken years, time that Germany didn't have. And finally, the Nazi ideology itself stood in the way. National Socialism was built on the myth of Aryan superiority. To admit that the Americans, a mongrel race in the eyes of the regime, were building better tanks using mass production techniques would have been a political heresy. So Germany kept building Tigers and Panthers, magnificent machines that were too complex to build, too hard to fix, and too fragile to fight a sustained war. They remained trapped, bound by an ideology that demanded perfection and an industrial base that could no longer afford it. The final tally was a testament to the power of the assembly line. The United States built 49,324 Sherman tanks during the war. Germany built approximately 6,000 Panthers and 1,347 Tigers. The production ratio was nearly 8-to-1 for medium tanks alone. But the effective ratio on the battlefield was even higher, because the American tanks actually worked when they reached the front. A Tiger tank might be able to destroy 5 Shermans in a single engagement. It was a terrifying opponent. But the grim calculus of the war meant that there would always be 6 more Shermans arriving the next morning, fueled, armed, and ready to fight. Meanwhile, the Tiger would be sitting in a field with a broken transmission, waiting for a replacement part that was sitting in a bombed-out factory in the Ruhr. The mathematics were brutal and unforgiving. German tankers achieved kill ratios that would have won any other war in history. But this war wasn't about kill ratios. It was about logistics. It was about flow. It was about the ability to sustain combat operations over thousands of miles. War Daddy 2, the captured Sherman that had hummed its way across the Tunisian desert, had shown the German engineers exactly why they would lose. It wasn't a warning delivered with a roar of gunfire. It was a warning delivered in silence. A tank that started when you pushed the button. A transmission that lasted the life of the vehicle. An engine that any mechanic could service in a muddy field. A gun stabilizer that allowed the crew to shoot first. These were not glamorous features. They didn't look impressive on a propaganda poster. But they were the features that won the war. Reliability beats perfection. Availability beats capability. A working tank beats a superior tank every single time. As the Third Reich crumbled and the Allied armies poured across the Rhine, the surviving engineers at Kummersdorf could only watch as the endless columns of Shermans rolled past the wreckage of their own broken masterpieces, the final proof that in the end, the amateur Americans had understood the professional art of war better than the masters themselves.